Hi all, welcome to SQL Server. Now on we will start SQL Server tutorials. So part of this tutorial I am going to cover all these topics: basic discussion on database systems, comparison between file systems and relational databases, explaining the relationships in a sample database, introduction to a basic select statement, where class and other basic operators in between like predicate, and group by class having aggregate functions, usage of case when, other string functions, date functions, conversion functions, and derived tables. So there are many of SQL concepts. So I listed all of them here. I will go through each and every one part of our SQL Server tutorial. So these are all the topics I am going to cover in our tutorial. So first, basic discussions on database systems, database management system. So part of this I am going to cover introduction, database system and hardware, required software, data and users. Coming to the introduction, data. So in general, data is nothing but a raw fact data and normal figures or any other numbers. Example: name, roll number, invoice number, any other attributes comes under data. And information. So information is a more meaningful data, processed or more useful form of data. It helps in decision making process. Means the information has some meaning or it is expressed something useful. The example for information is a timetable, merit list, progress card. All these have some structured information. It shows some purpose or some reason. And knowledge. So knowledge is nothing but it's an information containing some wisdom. It's derived from fundamental data processing and organizing. So it's a diagrammatical representation of data and input, how it's processed and what it becomes, information and output. So here this is the difference between data and information. Data is a complete raw information before processing. After processing, we will make the information with appropriate relations and will make it as a information, and that is nothing but an output. And next is database. Database is a related information when placed in an organized form makes a database. So database is few sample examples are dictionary, telephone directory and any other data systems. Here database contains an organized information. If it is an unorganized information, there is no meaning and it's very hard to identify the information from this unorganized list. And the common operations that we can perform on the database are selecting some data from the database, inserting the new data into the system, updating the existing data, or deleting unwanted data from the database. These are the common operations that we can perform. And building blocks of database. Building blocks of database are nothing but the operators or entities that we are using in the database. Here those are columns, rows and tables. Coming to the columns, columns are nothing but fields, that is an individual item of a data that we are storing in the database. And rows are similar to records as they contain data of multiple columns. Rows is nothing but we can call it as a tuple. And table is a logical group of columns and rows. And next, characteristics of database. So the characteristics are nothing but the kind of data that we are storing in the system. So it's an organized information and related information that we are sharing, and permanent or persistent data, validity, integrity and correctness, security, consistency, non-redundancy, independence, easily accessible data, recoverable, flexible to change, nothing but update, modify or delete. And next is ACID properties. The major properties in the database systems are ACID properties. Here these are the set of properties that guarantee that database transactions are processed reliably, referred to as ACID: atomicity, consistency, isolation, durability. Coming to atomicity. Atomicity refers to the ability of the database to guarantee that either all the tasks of a transaction are performed or none of them are done. Means in a single transaction, whatever the operation that we are doing, atomicity guarantee that all of them are done or none of them are done. And other thing is consistency. Consistency property ensures that the database remains in a consistent state before the state of the transaction and after the transaction is over, whether it's successful or not. And the next one is isolation. Isolation refers to the requirement that other operations cannot access or see the data in an intermediate state during a transaction is performing. Means while we are updating or inserting data, the other users can't see or access the data middle of the transaction. That is isolation. And durability. It refers to the guarantee that once the user has been notified of success, the transaction will persist and not be undone. That means it will survive the system failure and that the database system has checked the integrity constraints and won't need to observe the transaction. Most of the databases implement this durability by writing all transactions into a transaction log that can be played back to recreate the system state right before a failure, and a transaction can only be deemed committed after it is safely in the log. These are the IC properties of our database. And database management system. It is nothing but a set of programs that organizes and maintains the information or nothing but data. Primary goal of DBMS is to provide convenient environment to retrieve and store the database information. DBMS supports both single user as well as multi-user environments, and it ensures the data accuracy is nothing but data integrity. And few DBMS in our markets are DBase, Oracle, SQL Server, etc., and we have some other. And here these are the few components in DBMS environment: hardware, software, data, users, and procedures. We'll go through each and every one. Hardware contains computer systems, storage devices, input-output devices, and database work on microcomputers to large mainframes. And coming to the software. Software is the actual DBMS interface between physical data and users. And it requires handled by the database management system, provides simple interface mediated between database and users, and utilities are nothing but reports or any other progress kind of things. Example for software is MS Access and Oracle. And other next thing is data. The most important component of DBMS is the data. It's between machine and user. And users, we are having different users in our database management system, and different users can access different levels of data depending on their degree of expertise. Here users are classified in the following groups: native users, nothing but some ATM users or some other users; online users, application programmers, sophisticated users, and database administrators. Here few of the advantages of database system: controlling redundancy, integrity can be enforced, inconsistency can be avoided, data can be shared, standards can be enforced, restricting unauthorized access, solving enterprise requirement and individual requirement, providing backup and recovery. Cost of developing and maintaining system is lower. Data model can be developed and concurrency control. And few of the disadvantages are complexity, size, performance, higher impact of failure, cost of DBMS, and additional hardware cost and cost of conversion. And here the major part is difference between file management system with DBMS. Here, what is file management system? It is the first method used to store the data in a computerized database. Here the data item is stored sequentially in one layer file. Here a particular relationship cannot be drawn between the items other than the sequence in which it is stored. Here the difference between these two are: file management is a simple system whereas DBMS is a large system. It's relatively cheap, DBMS is expensive. It's a simple structure whereas DBMS is a complex structure. File management might chances of having redundant data, where we can see the reduced redundancy with some other operations. Chance of inconsistency in file system, DBMS is a consistent data. In file management, there is no data security. Here we can implement the security. Here it's isolated data. Here DBMS data can be shared. Often file management is a single user, DBMS is a multiple users. And some other disadvantages of file management systems are locating and retrieving a record is very tedious process because of its sequential access method, and altering the file structure such as updating a record is also a cumbersome. To do this, nothing but to altering the file, the entire file system has to be rewritten. So these are few disadvantages of file management system over the database. And the other thing is, now we will see relationships in a sample database. So relationships are nothing but, in the database we have few set of entities. Entities are nothing but the terms that we are using in the database. One thing is the entity. Entity is an object or a place, person, concept or activity about which an enterprise records of data. And types of entity is nothing but it's a details of an entity such as name, price, description, some other things. And attribute, it is the characteristic property of an existing entity. And attribute type, it's a property of entity type. Now we will see the relationship among the data. A relationship is defined as an association among entities. A relationship type is an association of entity types. Here again, a relationship may associate an entity with itself. So we have several relationships may exist between the same entity, and there are the types of one-to-one relationship, one-to-many, many-to-one relationship, many-to-many relationship. So now we will see some other logical models based on the records. So record-based logical models are used to describe the data at the conceptual and views level. And other model is network model. So the data in the network model are represented by collection of records, and relationships among the data are represented by some links or some other arrows, which can be viewed as a pointers. The records in the database are organized as a collection of arbitrary graphs. I will show you a sample relationships in a table. I will take here I will take an employee table and employee salary table. Employee salary, here we have employee ID, here we have salary. In employee table we have employee ID and name. The name is ABC and second name is XYZ, and just assume the salary is some 1000, and for the second employee the salary is 2000. So here this employee table has related to employee salary table. This table contains the salary of each and every employee. This table contains employee details. So it's a one-on-one relationship between these two tables when we have similar kind of records or aggregate salary. Whereas if we have multiple salary records for each and every employee for each and every month, then it is a one-to-many relationship between these two tables. These are kind of relationships in our sample database where we can maintain these relationships using some foreign key constraints. In our next part, we will see select statement, where clause, and some other basic operators in our SQL server. Thank you.